All right, let's go over the lab if you need help. In class, we decided that we would shoot the rocket straight up, and we would measure the time between the launch and landing. Then we would halve that time because at the top, velocity would be 0. Then we would use acceleration equals v final minus v initial over change in time to figure out our v initial. And we had negative 9.81 equals v final, again at the top is 0 because the rocket stops, minus v initial over change in t. Now change in t, we had those 3 launches. All of y'all had some time measured, and therefore you wrote it all down, and we ended up with, when we averaged all of our 18 times, we ended up with 4.80 seconds. Now notice this is 3 significant figures, and that's what we're going to be using. So determine the speed of the rocket, show your work below. So again, we use the acceleration formula, which is v final minus v initial over change in t, and in our case it's the acceleration due to gravity, which is negative 9.81. So negative 9.81 equals, and then you have 0 minus v initial. Now the important part is, remember we said when we figure out our time, we're going to divide it in 2. So our half time is 2.40 seconds. So therefore, negative v initial equals negative 9.81 times 2.40. And I'm keeping all those 0 so that when my answer has 3 sig figs, my potential teacher cannot say, oh, you lost one of your sig figs. So keep your sig figs intact. So your answer is 23.5 meters per second. What just happened? Okay, I hope it's still recording. So 23.5 meters per second is our velocity. And again, this is the launching speed. With this speed of 33.5 meters per second, our rocket would launch, get off the stand, under the pressure of air that the pump would be pumping into the stand. Anyway, calculate the highest point. So for the highest point, I gave you 3 options. I gave you delta y equals v initial plus v final over over 2 times change in t. Then you had an option of change in y, a slightly longer version, v initial change in t plus 1/2 g change in t squared. And then the third option was v final squared equals v initial squared plus 2g change in y. You could have used either one of those 3. I'm going to just for fun use all 3 and show you that indeed you will have the same answer. So change in y, here I will just straight put the v initial, which is 23.5, we found it, plus 0 over 2 times, now remember, the maximum point will be reached in half the time, so times 2.4. So that gives me 23.5 times, basically 1.2. Gets me 28.2 meters. That's one way. Change in y equals 23.5 times, again, half time. That's how long it took to get to the top. Not 4.8, but only 2.4 seconds. Plus, and be careful, you are going to add 1/2, but remember that 9.8 is downward, and therefore it's going to be negative. And then times 2.4 squared. 23.5 times 2.4 minus 0.5 times 9.81 times 2.4 squared. Voila, it is 28, well technically it says 28.1 meters, but that is due to some rounding. And then v final squared, here I have 0 equals 23.5 squared plus 2 times negative 9.81 times change in y. So then change in y is going to be negative 23.5 squared over negative 19.62. You can forget the negatives. So it's just 23.5 squared divided by 19.62. You get 28, again 28.1 meters. So the difference is just in a tenth of a meter, 10 centimeters. It's not that big, and that is due to using a rounded time. All right, so whichever way you wanted to use, you are welcome to use the one that makes more sense to you. Then the question was, what would we do? I mean, what would we observe? What would be the path of a rocket if it was shot at 30 degrees to the horizontal? So our 23.5 is at 30 degrees to the horizontal. So that tells us that our rocket at 30, our rocket is not shot straight up, so it doesn't only have vertical velocity, but it also has horizontal velocity, and therefore the path is not going to be straight up, but it's going to be up, 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 up. And down here at the very top, Vy will be 0, but the Vx is going to be the same. So remember, we can say this is Vy initial and this is Vx. You're welcome to say it's initial, or you're welcome just to say it's Vx, because remember, in projectile motion, we assume there's no air resistance, therefore there's no change to Vx. So at the top, it's still going to be, so then the question, would the rocket be at rest? Big no, because right here, it still has Vx, because there's no air, no acceleration. All right, so then draw the velocity arrow at 30 degrees, 23.5 meters per second at 30 degrees. Then Vx is going to be 23.5 times cosine of 30 degrees. And Vy initial, and we have to say initial because it will change throughout the flight. It's going to be 23.5 sine of 30 degrees. So use your calc times cosine of 30. That gives you 20.4 meters per second. And vertical is going to be 23.5 divided by 2. So it's 11.8 when you round meters per second. So that would be our two velocities, and you have to distinguish between them. This is x. I mean, this is y, and this is x. So this is vertical, and this is horizontal. Now, the next question was, what if we take the same rocket, but shoot it at 60? Now, 60 and 30 are complementary, which means where we had cosine, so if this is 60, we now have 23.5 cosine of 60, which is the same as sine of 30. So this becomes 11.8 meters per second here, and this becomes 20.4 meters per second for the vertical part. All right. I don't know if it was recording, but whatever. So if it's shot at 60, it's the same as before, 23.5 right here. And since it's a different angle of 60 instead of 30, then sine and cosine flip, and you have a higher vertical velocity versus lower horizontal velocity. In which case would the rocket stay in the air longer? Explain why. Shot at 60 degrees because it has V initial y that is greater. And then you can say G equals 0 minus V initial y over change in t, same for both. This is greater for 60. So therefore, time is going to be also greater for 60 degrees. All right? If we were to calculate it specifically, again, we're using, see how it says, use the formula for acceleration to calculate the time. So you are looking for change in t for both of them. If I rearrange the formula right here, then I will just, whenever you're looking for something in the denominator, you just swap. So you have change in t equals 0 minus v initial, and it's v initial y obviously, divided by g. Same thing here, 0 minus v initial y over g. So if I'm looking for 30 degrees, the one for 30 was 11.8. So change in t here is going to be 0 minus 11.8 over 9.81. That gets 11.8 over 9.81, 1.2 seconds. And this change in t is going to be 0 minus, I believe it was, what, 20.4? 20.4 over negative 9.81. And then gets us 20.4 over 9.81, 2.1 seconds. Now, be very careful. This is only half time. Because remember, velocity becomes 0 at half time, and then the next half of the time, velocity becomes negative of what it was before. So it flips and goes down. So total time is going to be 2 times 1.2, and it's going to be 2.4 seconds. And here, change in t is going to be 2 times 2.1, and it's going to be 4.2 seconds. So that, I believe most of you were on task for that and managed to figure it out. So make the general rule about how the time of a projectile changes depending on the angle to the ground of the launch. So if I say V1 equals V2, like if we take the same rocket and shoot it with the same speed, then as the angle increases, so for example from 30 to 60, V times sine of theta also increases. So Vy initial is greater for a greater angle and then if again you are relying on the formula of acceleration, 0 minus v initial over change in t, time is greater. So when you shoot a rocket or any kind of a projectile, the higher the angle to the ground, the longer the time in the air. Do not relate to, oh, it's going to go higher. Well, it's going to go higher. Why? Because it has a greater initial velocity. Therefore, it's going to spend a longer time in the air. And therefore, because of the greater vertical velocity, it will also reach a higher point above the ground. Now, remember when we were drawing the trajectory, we mentioned that at the top, our projectile will still have its Vx. Well then, which projectile at 30 or at 60 will have a greater Vx? The one that had a smaller Vy. So remember, when we looked at our shot at 30, we get 20.4 meters per second. But if we shoot at 60, we flip them, and now horizontal is lower, 11.8. So the one shot at 30 degrees, because Vx is greater at the top. The rocket only has Vx. There you go. Calculate the horizontal and vertical ranges of the rocket. This is what most of you stopped. This is where most of you stopped. So I will run another video. I'll see you if you need help with that.